Welcome back, everyone, to Nelson Math, Chapter 7, Section 5, Sorting Polygons. As you've done in the past, you've found different properties of polygons and you have sorted them in the appropriate way. So we're doing that today with polygons. We're going to identify the lines of symmetry in each of these polygons. The easiest way to do this would be to cut them out and then fold them. However, you can also do this with a transparent mirror, which you call mirrors. So we're going to be doing that now, but you'll have to take my word for it because I can't really cut them out on my screen. So let's start off with this rectangle right here. For this rectangle, we have exactly two lines of symmetry, and those lines of symmetry run directly vertical, and it's hard to tell with this color, but I'll see if I can darken it up. So here is one line of symmetry. It's not exactly straight, but it's not letting me make it directly straight like that. And it has a second line of symmetry. The line of symmetry goes this way, right there. So when you fold them along this line, they land exactly on top of the other. And there are exactly two lines of symmetry for this rectangle, one going horizontal and one going vertical. For this trapezoid, it only has one line of symmetry. Let's see if we can find out why. For us to fold this trapezoid, we'd have to fold it right there. Then this left side would land exactly on top of this right side. This, which is different than the rectangle, if we folded it along this line, we would not get the two halves folding exactly one on top of the other. It would only be some overlap. We wouldn't have exactly traced one over top of the other. For this hexagon, it has this line of symmetry. It only has one horizontally, so that's one. If we fold it along this line, it would fit exactly over top. And it has one vertical line of symmetry, which looks like that. So here's our vertical line of symmetry. So this one has two lines of symmetry. Now let's take a look at the chevron. This chevron only has one line of symmetry. If we folded it along this line right here, we would get exactly over top of the other, exactly this piece over top of this piece with no overlap. This parallelogram, the way it's drawn, has exactly 0 lines of symmetry. There is no way we would be able to fold this parallelogram so it lands exactly one half on the other half. It would just never fit any which way that we did it. It would always have some overlap. So there are 0 lines of symmetry here. I left this octagon until the end just so I could point some stuff out. I've drawn numerous lines of symmetry here already. It doesn't matter which line you see here. If you fold it across, right across, let's take, for example, this line that's straight vertical right here. So this line that goes directly up and down. If you fold it along this line, it would land exactly one side, one half on top of the other half. And that could be said for any single one of these lines. However, there is going to be a bit of a problem when we count the lines of symmetry. If we start counting, let's say from right here, so the top right one, along the top on the right side, we counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We would count 16 lines. However, we've counted each of these lines twice. Let me show you why. Watch what happens when I move this line out of the way. Totally moved out of the way. Now I'm going to move this one out of the way. and this one out of the way, and this one, and this one, and this one, and this one, and this one. So if we count all of these lines, 1, 2, 3, 4, 5, 6, 7, 8, we have 8 lines of symmetry. The reason we counted them twice accidentally was because with all of the lines crossing here in the middle, it's cutting each of the other lines in half. This is in fact one line of symmetry, just one. So once we take this one out, now we can take this one. This is also exactly one line of symmetry, exactly one. But if we count it from both the start and the end of the line, we're going to count them all twice, which is not what we want. Every one line of symmetry counts as just that, exactly one line of symmetry. Thanks, everyone. Have a good day.